What if AI could learn, not just from mountains of data, but from each other? We're about to dive into this really groundbreaking idea. What happens when you take AI out of its solo training session and put it into a classroom where other AIs are the teachers? Let's get right into it. I mean, just think about how we learn, right? We don't start from scratch every single time. We learn from our parents, our teachers, our friends. It's a social thing. So the big question behind the research we're digging into today is, what if AIs could do the exact same thing? And this slide just lays it out so perfectly. The old way versus the new. On the left, you've got this every AI for itself model. It's like a digital Robinson Crusoe, totally isolated, super inefficient. But then, on the right, you see the new idea. A whole community of AIs learning together, building on each other's wins. And the result? It's way faster, way more efficient, and you end up with a much more sophisticated, structured language. All right, so let's really get into the core challenge here, which is this huge communication problem that AI has. I want you to imagine a room full of the most brilliant people on Earth, but none of them speak the same language. That's pretty much the messy reality when you try to get a bunch of AIs to work together without a shared way to communicate. Now, the fancy technical term for this is emergent communication. Basically, it's like this. You put a group of AIs into a simulation where they have to, say, negotiate over some resources to win. You don't give them a language. They have to invent one from scratch. That's emergent communication, language born purely out of necessity. But here's the problem. When every single AI is trying to invent its own language at the same time, you just get chaos. Total digital chaos. They all end up exploring the same dead ends, they waste a ton of time and energy, and the languages that do pop up are often really, really basic. It's kind of like trying to get 100 people to invent grammar, but they're all in separate soundproof rooms. It's just not going to work well. So how do you fix this digital Tower of Babel? Well, the researchers came up with a solution that's surprisingly human. They asked, what if, instead of every AI learning all alone, they could actually teach each other? So they built this framework called TSLEC. That stands for Trust-Based Social Learning with Emergent Communication. Now that's a mouthful, but the core idea is actually super simple and really powerful. When an AI figures out a strategy that works and works really well, it doesn't just keep that secret to itself. Nope, it becomes a teacher and shares that knowledge with everyone else. And the whole process works in this really neat 4-step cycle. Okay, so first, one agent stumbles upon a great strategy. Step 2, it becomes a teacher and shares that strategy as a lesson. Then, and this part is absolutely crucial, the other AIs test out that lesson to see if it actually helps them. And finally, if the lesson works, that strategy gets adopted by the whole group, and the teacher who shared it gets a little reputation boost. And that brings us to the secret ingredient that makes this entire system tick. I mean, in a world full of digital chatter, how does an AI know which lessons are gold and which ones are just noise? Well, the answer is one simple word: trust. You know, it's a question we ask ourselves all the time, right? If you get advice from 10 different people, how do you possibly decide who to listen to? Well, the AIs in this TSLEC system, they face the exact same problem. The solution they came up with is this internal trust score, and it's super intuitive. If a teacher shares a good strategy and the student AI's performance gets better, boom, that teacher's trust score goes up. But, and here's the clever part, if they share a bad strategy, their trust score takes a big hit. It plummets. This design, where trust is earned slowly but can be lost in an instant, basically forces the teachers to only share their absolute best stuff. Okay. So the theory here sounds great, right? Social learning, trust, it all makes a ton of sense. But does it actually work in the real world? Or, in a complex computer simulation? Well, the researchers put TSLEC to the test to find out. So this is the million-dollar question. Did adding this whole social layer, this teaching and trust, actually make any real difference compared to just letting the AIs figure it all out on their own? And the answer was a huge, resounding yes. I mean, a massive difference. The AIs using this social learning system mastered the task almost 24% faster. Think about that. Just by sharing knowledge, they cut way down on wasted effort and zeroed in on the best strategies so much more quickly. And this chart really just drives the point home. Look at that bar on the far left. That's the full TSLEC system. It achieved a much higher final reward, a much better score. Now look at the middle bar, where agents had no teaching. It did worse. And then the bar all the way on the right, the lonely independent learners, dramatically lower success. It's crystal clear. Teaching makes a huge, huge difference. But here's what's really cool. It wasn't just about being faster. The language that came out of this teaching process was just better. It was way more structured, more systematic. The researchers measured this with something called a compositionality score, which is basically a way of measuring how much a language has real grammar-like rules. And the social group's language was just far more advanced. It's like the difference between a few random grunts and a language that has actual grammar. And here's the smoking gun, the proof that the trust system was really the engine driving all this success. The researchers found a super strong positive correlation, that's the R equals 0.743 number, between an agent's trust score and how good its teaching actually was. So what does that mean? It means the AIs got really, really good at figuring out who the reliable experts were and who they should just ignore. Trust wasn't just some fluffy add-on. It was an incredibly effective filter for good information. Okay, so this is all super fascinating in a computer simulation, but why should any of us care? Why does it matter in the real world? Well, this is where it gets really, really exciting. Just imagine fleets of self-driving cars that can seamlessly negotiate intersections because they're constantly teaching each other the best way to do it in real time. Or think about a smart energy grid where thousands of devices are coordinating with each other to prevent blackouts. This is the blueprint for that kind of super fast, robust, and efficient teamwork. So if there's one big takeaway from all this, it's this beautiful feedback loop. See, the act of teaching itself creates pressure to develop a better, more structured language. And then having that better language makes the teaching way more effective. Social learning and language evolution, they literally fuel each other's growth, just like they do for us. And this research really leaves us with a pretty profound question to chew on. We tend to think of something like trust as this uniquely human thing, right? But if we can build artificial systems that can actually learn to build trust with each other, well, what's the limit to what they can achieve together? It's something to think about.